Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to find the derivatives of logarithmic functions. So here's what I'm talking about. I'm saying I give you a function like this, and you tell me what's the derivative. And I'll just tell you the answer is, for this famous example, natural log of x, it's the easiest one. The answer will always be just 1 over x. However, sometimes it's more complicated than that. Sometimes you have natural log of something in parentheses, like let's say x squared plus 2x. And in those cases, the derivative is still pretty easy. The first thing I do is I put 1 over x squared plus 2x, but then because of the chain rule, I have to multiply by the derivative of the thing in parentheses. In other words, the derivative of x squared plus 2x is quantity 2x plus 2. And if you don't know that, then you should not be watching this video because that's just easy power rules. And so then the simplified final answer would just be this. You would write in the numerator 2x plus 2, in the denominator x squared plus 2x. And that would be our answer. Now a couple things I want to say about this. Number one, if you think a 2 cancels, because just look at this. There's like 4 2's here. Well, the problem is the 2 does not cancel out because it would need to show up in every term, and it does not show up in the x squared term. If you wanted it to cancel, it would have had to have been 2x squared, which it is not, so it does not cancel. And then the second thing I want to say is, the way I usually do these derivatives, I'll just skip this chain rule step right here. I always just say, if I have the natural log of something, whatever it is, then the derivative of this is always going to be the derivative of the thing in the numerator divided by the original in the denominator. This is what I always say. Notice there is no natural log in the derivative, which is important. It's just the derivative of the thing over the original. Now you'll notice everything we've done so far is natural logs. What do we do if it's log base something else? Like for instance, what if I have log base 3 of x? How does this change my answer? Well, I will tell you. There's a long way of doing it and a shortcut method. I'll show you both. The long way of doing it involves using the change of base formula, which is the only time you ever use the change of base formula, like ever in math. It's for this purpose right here. And change of base formula says that you can rewrite log base 3 of x into natural log of x divided by natural log of 3, your base. Technically, you don't have to choose natural log. You can choose log base literally anything. Like if I really wanted to, I could do log base 22 of x divided by log base 22 of 3. But the reason why I don't do this, and I don't do the common log either, which is log base 10, I only do natural log because natural log is the only one I know the derivative for. So in other words, when I'm thinking the derivative of this, the natural log of x, that derivative is 1 over x. And then the natural log of 3 in the denominator is not a quotient rule because it doesn't have x in it. It's just a coefficient, so it's divided by natural log of 3. And if you know how to reduce this correctly from algebra 2 or pre-calc, you would know that the best way to write this is 1 over x natural log of 3, which is the best final answer. Now again, that was the long way involving the change of base formula. The shortcut way that I'm going to tell you now, you don't need the change of base formula. You literally just need to remember if you have log base a of anything where a is any constant, any number, 2, 3, 1 million, whatever, then the derivative is, assuming this x can also be anything like x squared plus 2x or whatever, then the derivative is going to be the derivative of the thing in the numerator. That didn't change. In the denominator, it's the original times the natural log of whatever your base was. In other words, that a right here. So if that was a 3, it'd be natural log of 3 in the denominator. If you ever have log base e, which is the same thing as the natural log, then that would be the natural log of e right there. And what is the natural log of e? That's right, it's just 1. Which means whenever we have natural log or log base e, we love it because that means there's just a 1 in that position. And what's 1 times anything? It stays the same. Which is why when I first gave you this formula right here, and I said the natural log derivative was the derivative over the original, I didn't even need the natural log in the denominator because the natural log is a shortcut. It's our favorite logarithm. to take the derivative of, because we know it's going to be the easiest form of the derivative. Now, maybe I confused you a little bit with that last part. Don't worry, we're going to be doing some example problems right now, so go ahead and practice along with me. Pause the video, try it on your own before I show you the solution. So for the first one I want you to find the derivative of y equals natural log of 5x. And once you find the derivative, I'll give you a hint, this one can be reduced. So go ahead, give this one a try, using our rules that we said earlier. Okay, so first things first, derivative y prime equals, just take the derivative of 5x, that's the numerator, and of course the derivative of 5x is just 5, and then in the denominator is the original 5x. And normally this would just be the final answer. However, since the 5's do cancel here, like that, then all you're left with, final answer, is y prime, or dy dx. If you like to write dy dx, that's okay too. But the derivative is just going to be 1 over x. And there's our answer. So in other words, it looks like the derivative of the natural log of 5x does have the exact same derivative as natural log of just plain old x, which is interesting. So now let's do another one. We have f of x equals natural log of 9x plus 13. Go ahead, pause the video, give this one a try, and when you're ready to see the solution, unpause. Okay, so here we go. First, f prime of x equals, in the numerator goes the derivative of 9x plus 13, which is simply 9, because the derivative of plus 13 is 0. And in the denominator, we have the original 9x plus 13. And again, I ask myself, does anything cancel? Do any of these three terms have anything in common in terms of their factors? And the answer is no, they don't. So this is my final answer, and I'm happy. Okay, hopefully it's starting to make sense now. Here's number 3. I have h of x equals log base 2 of x squared. You'll notice it's not natural log this time. I don't care if you do it the long way with change of base formula or the shortcut way, but go ahead, give this one a try now. Okay, and here's the solution. H prime of x equals, I'm going to do the shortcut method, which just says to put the derivative in the numerator, which derivative of x squared is 2x, and in the denominator is the original x squared times the natural log of my base, which in this case is 2. This 2 right here to be exact. And then I ask myself, does anything cancel out? First I want to say, do these 2's cancel out? Nope, because the second one in the denominator is inside the natural log, which means it cannot cancel out. However, one of the x's will cancel out, and a lot of you out there will miss this. This x cancels out with the x squared, leaving you with 1x in the denominator. If you're wondering, really, you can do that? The answer is yes, because in the denominator it's multiplication, and clearly we have division going on here with the fraction bar. In other words, since there's no addition or subtraction, it's very common that we see x's cancel out. And you need to spot that because it's important or you're getting the wrong answer. So then the final answer here is 2 divided by x natural log of 2. The parentheses are optional around the natural log of 2. In other words, if you just write this, this is fine as well. As a matter of fact, you can even put the natural log of 2 first instead of the x. But as long as they're both in the denominator, you are good. And that's basically it for this one. Hopefully you got it right. And now we just have one more problem for today, number 4. I have y equals the natural log of big set of parentheses here with a big fraction bar in the middle. In the numerator, I have 3x minus 4, and in the denominator, I have x squared plus 1. And so for this one, I do not want you to try this on your own. The reason why is this is kind of a trick question. I'm going to cover this one in a different video. Basically, if you were to try this the normal way, like the way I just taught you, you'd have to take the derivative of this, which involves a quotient rule, g times f prime minus f times g prime all over g squared. And I don't want you to do that because it would take too long, there'd be a complex fraction, there'd be a lot of simplifying to do to get your final answer, and ultimately there is a better way to solve this problem using our properties of logarithms that we learned in pre-calc. And so for that, I will be covering this problem in a different video, should be in the description below. And so for that reason, we are going to end right here, not even solving this problem. If you have any questions, please post them in the comments below. Thank you all for watching. My name is Dan the Tutor, and I'll see you in the next video. Take care, and bye-bye.